be able to. All right. Hey guys, welcome back. So today we'll be looking into writing Solidity smart contracts. Okay, so let's just wait for another. Okay, it's already 6 p.m., 5 p.m. So let's just. All right. So let's open up Remix. So let me open up Google. Okay. All right, cool. Let me get this on the other screen. Okay. So here we'll open up Remix. So I'm gonna type remix .ethereum.org. Remember Remix? Yesterday we did go to Remix, right? We did look into what is Remix and everything, right? So you can go to Remix and then get all get everything set up. Get basically your all like your development ID set up. Okay. Now. Okay. Great. Got it. Okay, so now let's create a new workspace. So I'm going to create a new workspace here by clicking on this plus icon. Okay, so I'm going to say crowd funding, and this is optional. You don't have to do this. I currently do this because so that I can keep everything separately organized. That's the reason. Okay, so we have around three by basic contract here, so you can ignore them. You can just create new one. We'll call it for underscore crowd funding. Okay, crowdfunding.sol. Okay, let's say crowdfunding.sol here. All right, so yesterday we did go through like how we can develop our contract, right? So what is the first thing that you have to do? The first thing that you have to do is you have to set up pragma solidity 0.8.2. So you have to define your solidity version. It can be 0.8.2 or 0.8.0, 0.8.5, anything. Okay, so hopefully let it be in 8 version or 0.8 series, so that will get all the updated versions. Okay, all the updates of the latest solidity version. Okay, and now we will write our first contract. So we'll say contract crowd funding. Okay, and then we'll open up the braces. So now we completely we have written our contract. So we have the base contract ready. Now let's start adding the contract body. Okay, so first thing is, let's say what do we need here. So let's say what we'll be doing here. The first thing that we'll be doing here is we'll be enabling users to add projects. Okay, so basically in the application, right, when user enters the application, they will get all the list of projects available from the contract. Okay, and then user can select any one of the project and they can read the description of that. They can read the title. Okay, and if they like the project, they can click on fund. Okay, when they click on fund, they can transfer ERC20 tokens. Okay, so basically we'll be writing two contracts. One is crowdfunding, another one is ERC20 contract, which is very simple. Okay, and people who wish to add their own project, they can click on create project or add project button, and then they can submit their project details, and then they can add the project to contract. Okay, so now we will say crowdfunding here. So here what we'll be doing is we have to first create how the project looks like, right? We need a base structure of the project here, right? So you cannot actually maintain it something like a event id of the project, something like this, right? Event id equals 0 and or having an array of values and everything. So that shouldn't work here, right? So what we'll do is we'll actually define the structure of the project data using struct. Okay, so we'll define a type of project. Okay, so this project will have an id. We'll say event 256 project id. Okay, and then we'll have a string of title. Okay, and then we'll have another string for description of the project, and then we'll have another string that says image, like basically the image of the project. Another string the event that says funds required. So what is the amount of fund that the project required. Okay, and then we'll have a boolean value that says is active. This is basically, this is, if you can actually ignore this, but the thing is, let's say in the future you want to improve this and you want to see whether the project is active or not. Let's say if you want to enable the project owners to stop funding for some times. So you can use this value. Okay, you can make this as false so that only active projects can get funded and inactive projects cannot get funded. Okay, so you can do that as well. So we'll add one more value that says total funds received. Okay, total funds received. Okay, so this is the required and this is the total funds received at till now. Okay, till now, till date. Okay, and then we'll have one more event that will say available to withdraw. This is really important because let's say my fund is 1 million. 1 million, I require 1 million funding and I get around what do you say 0.5 million. Okay, currently 0.5 millions is total received funding, and in that the available to withdraw will be 0.5 million. So I can withdraw all those 0.5 million, right? So let's say I withdraw only 0.1 million. Out of 0.5 I withdraw only 0.1. Now the available balance for me to withdraw should be 0.4, but if you don't have this will keep pointing to 0.5. Okay, even if you withdraw that, it will still say 0.5 because this is total fund received. It doesn't say this is how much you have balance. Okay, so that's the reason we have to make sure that we have another variable where we can store the amount of value that can be withdrawn. Because what the project owner can do is, let's say we don't have this, project owner can like say they receive 0.5 million dollars of funding. So project owner can withdraw all those funding and make this to 0. So now it will users, when they come back to project, they will think like, okay, this project doesn't have any funding, it's still 0, and they start funding again. So even though he requires only 1 million, he can get more than 1 million with this. Okay, so that's the reason we'll have one more variable to store how many amount of tokens to withdraw. Okay, now even if I withdraw 0.1 million, so the only the remaining that's available to withdraw will be 0.4, and the total received funding would be 0.5. Okay, out of 1 million. So now the owner cannot like the project owner cannot cheat or cannot withdraw more than what he has. Okay, at last we'll have address or the project owner. So I'm gonna call this as owner. Okay, this will be project owner. Okay, and next thing is we need one more struct. Okay, we need one more structure that says project input. Okay, project input. So basically the functions which we write to get the project data, like basically to list the project. So this is how we actually get the input. So here I'm going to say string title and then string description. Okay, and then event funds required and then string image. That's it. So now we need this because like you cannot pass like more than 4 to 5 parameters in a function in Solidity, not after 8 version. Like after 5, I think after Solidity version 6 or something, you cannot pass more than 4 to 5 variables. Okay, more than 4 to 5 arguments for a function. So you need to define a structure for this one. Okay, since we have 4 here, and let's say we might need 1 or 2 more parameters for a function and we cannot do it, we will exceed the limit. That's the reason we'll add this structure. Okay, so this will enable us to properly pass the values. Okay, and then now okay, we have a project structure here, but how do we store all the list of projects we get? We need to store it in some way, right? So for that we'll use mapping. So for that we'll use mapping, and we will map event to project, to type project. Okay, event would be the project ID here and project would be the project details. Okay, and we'll keep it private so that no one else can actually get this value except the contract. Okay, and say projects. Okay, plural. And we'll also have one more value, that is an array. So we'll store array type of project, and we will call this as projects array. This is required because mapping stores everything in key value pairs. Okay, let's say you want to retrieve all the list of projects available. You cannot do that with mapping. It's very hard and it's not quite optimized as well. You have to loop, and you just have to write unnecessary loops. So in that case, what we'll do is we'll just store them in an array as well. So in case since it's an array, you can just return it all together at once. You don't have to do any map or loops or something. You can just directly return it if you need all the list of projects available. Okay, all right. Now let's just write our functions. Okay, all right, great. Now we'll say function. Okay, we'll say function list project. Okay, function list project. Now here we will accept a project input. So we'll accept a project input again here, right? We defined it here, and this will be in memory. This will be in memory, and I will say underscore project. Okay, this is a standard, like, naming convention to name all the parameters of a function. Okay, we'll say project, and here we'll say public. Okay, this will be a public function, and then we return. Okay, we would return a event. So we'll be returning a project ID from this one. Whenever the list project is basically adding a new project, and we return the ID. And if you want to like improve this particular code, what you can do is you can also add a documentation. You can add a documentation with 3 forward slashes. This is called NatSpec documentation way, or NatSpec standard. Okay, so we say notice. Okay, so we notice what is the description of the function to list or add projects. Okay, so notice would say what is the meaning of this function. Okay, and param, so we have one param, that is underscore project, and what does this do? Project details. Okay, so this is the project details, and this is also very good, because if you, let's say I add one more param, let's say param something, you can see Solidity is already throwing error. If you scroll on that, you can see no description given to something, because something is not there here, right? And we're trying to define it. So NatSpec standard is very very much integrated with Solidity, so it automatically detects that, hey, what you're trying to document is actually wrong. You don't have that parameter. It's just saying that. Okay, that's one of the amazing thing about Solidity. Now coming back, so we'll say project here, project memory. Okay, and project, so we are creating a new instance of that struct, the project struct. Now what we'll do is we'll basically add all the values. Okay, so here I'm going to say event ID, I'm going to say 0. Okay, we cannot have this 0, but I'll show you how to increment it. And you cannot in Solidity, it's very bad to have something like this. Okay, it's not good if you have something like this, event ID 0, and then you increment for every values. You shouldn't do that, like basically incrementing it like this. Okay, ID plus plus, this is actually valid, but you shouldn't do that. So there is actually a utility called counters, we'll use that. Okay, so for now, just for the demo purposes, I'll show you how to use that, but for now let's just write a whole function first. I'm gonna manually hard code it to 0 here. Okay, now we'll say project.id. Okay, project.id would be ID here. Okay, and project dot, okay, it's project, and where is this dot id come from? Here. Okay, and next thing we have is title equals, we get the title from here, underscore project input. See, input description, title description, everything is in project input, right? So we say project dot title. Okay, similarly, let's copy this whole thing. I'm gonna just copy then paste this multiple times, so that since I will be reusing that. And then here we need description, and this will have a description as well. And we need an image, this will have an image as well. Okay, and then we need funds required, and this will have funds required as well. Okay, and then right now we exhausted all the properties of project input. Now the only thing we need is total funding received. So total funding received initially would be 0, so we'll say 0. Okay, and then what is the next thing we need is if project is active, so we'll add that as well, is active to true, we'll set it to true. Okay, and next thing we need is available to withdraw, that would be 0 as well. Okay, so I think we covered everything here. Oh, we didn't cover owner. Other than that, everything was covered. So let's cover owner. So we'll say project dot owner equals msg dot sender. So msg dot sender is nothing but the caller. Okay, whoever is calling the function, they are the owners, right? So they can only they will be the owner of the project here. Okay, so you can see, what is this? Okay, so what it's saying is you're defining event, returns event, but you're not returning anything. So that's what it's saying. Since we're not done with the function yet, let's not worry about it. Okay, now you were able to define all the project details, but you didn't actually add it to this mapping, right? Mapping and this array. Now let's do that. So now we'll say projects, again plural, projects, this one. Okay, the mapping. So we'll say projects of id equals project. Okay, so project is here. Okay, so now we added this to mapping. So in mapping we have this. Now the only thing remaining is pushing it to an array. So we'll say projects array dot push project. So now we are pushing this to array as well. So we were able to first create the project details and then update, store it as well. And now it's time for us to return the ID. So we return the ID. That's it. So this will actually complete your list project function. It's not it. We actually had to add some more things here. The first thing is the ID is hard coded. So we have to change it to like, you know, somewhat dynamic, dynamic generation ID, like counter basically, and then also emit an event. So whenever there is a project added. So now let's try to work on the other functions first, and then we'll come back to this. Okay. So now we were able to list the projects. Now let's write a function to get the project. So here I'm going to say function get projects or get all projects. Okay, get all projects, get all projects. Okay, so this will be a public function as well, and this will be a view function because we won't be modifying anything here, we just be reading. That's why it's a view function, and we'll add returns. Okay, and then this will be a type of project. Okay, you know the structure we wrote, a type of project but an array. Okay, and we'll add this in memory. Okay, this will be in memory. Remember what is memory from previous class. Okay, and then we will return this. Do you remember this same data type that we had somewhere here on top? See, same data type, that is project array. So we'll copy that and then return that. Okay, that's it. So this will return all the projects. See, you don't have to do any loops or anything. So in case of mapping, if you didn't have this array, you should have mapped every single thing one by one and then check whether it exists or not and everything. That would have been really complex. Now we just return it. Okay, now let's write one more function that says get project by id. So now we are getting a project by id. So we'll say uint 256 project id. So we'll accept the project id, and we'll say again this will be public, this will be view as well because we won't be modifying anything here, and this will returns, okay, this will return a project type, not the array here but only one project. So we'll say memory. Again we say we'll return projects of underscore id. So we'll be returning the projects of id. Okay, what is this? Oh, okay, it is return, not returns. Okay, so there we go. So we have two functions now. Let's write an aspect documentation for this. So notice function to get all projects, and there is no parameter, so you can skip it. And here we go, one more function, that is, let's say notice function to get project by id, and then we'll add one more param. So for this we'll say id project id. Okay, so from the next functions I won't be writing this one, guys. So this basically you can write this on your own. Okay, so this is the format we'll be following, so you can write it on your own. Okay, because we have to add one more contract, so I don't think we'll be able to finish if we do all these things together. Okay, so we'll say function. So function, and we have two more functions. One is a fund project and one is withdraw tokens. Okay, withdraw funds. So now we'll write a function called fund project. So this is the main function where we actually fund the project. Okay, so we need to accept a uint of id, the project id, and then uint of amount, like what is the amount I need to fund. Okay, so here I'm gonna just leave some space here because I'll be defining a couple of, okay, let's do one thing. Let's define here, this will be a public function. Okay, and this won't return anything, we don't return anything here, but this will be public function. Okay, so now here, so we have to, first thing is we have to update like what is the amount of token we received. So let's say I'm sending around 0.1 million funding. So first thing is we have to check whether this project is able to like take this amount or not. Because let's say I need what do you say, 1 million of funding. From fund required is 1 million, okay, for my project. But if someone tries to send 3 million for that, I should reject it because it's more than what I need, right? We have to do all those checks, and let's not do those checks directly inside the function. Let's not code all those conditions inside the function. We'll have a modifier for that. Okay, for now we'll write modifier later after the functions. So for now let's take care of this one, like what is like all the amount of like how to all the calculations basically. So now we'll say projects of id dot total received funding. So if this is valid, then total received funding will be this amount will be added to the current total received funding. So if the total received funding is 1 million, and if I'm sending 0.1 million, then currently the total funding received would become 1.1 million. Okay, and we also have to update the withdraw as well. id dot available to withdraw equals amount. So what are we doing here is, let's say the currently the available to withdraw would be just 0.1 million, and if I'm sending 0.1 million, then the available to withdraw would become 0.2 million. Okay, so currently, let's say, let me write the comments here. Let's say the current value would be 1 million here. Okay, 1 million in total received funds, and I'm sending 0.1 million. 1 million. Okay, now the total value would become 1 plus 0.1 million, that is equal to 1.1 million. Okay, now the total received fund would become 1.1 million. But what if available to withdraw is just 0.1 million? Okay, then I'm gonna send 0.1 million here. Okay, my value here would be 0.1. So now what would that become? 0.1 plus 0.1, this would become 0.2 million. Okay, so this is how we update it. Okay, and of course we have to emit the funded event. We will write one more event called funded and we'll emit it. For now this is fine. Okay, we'll add all the conditions later after these functions. Okay, and next function that we'll be writing is withdraw. We'll say withdraw funds. Okay, withdraw funds, and then we need the project ID for this. We need to see which project I need to withdraw. Okay, so we need to see which project we are withdrawing the tokens from. So we'll say public here. Again guys, we need to add some more conditions here. We need to check whether the person who is withdrawing is actually the project owner. So for that we'll write modifiers. Okay, so before doing that we'll just complete all these functions. This is the last function, and then we'll write the modifiers one by one and then add them to these functions. Okay, so now we'll write uint 256 funds to withdraw. Okay, and this will be projects of id dot available to withdraw. Okay, again you can see that we're not actually referring total funds received, we're referring to the funds that is actually available to withdraw. Okay, and now we actually say require. We check one thing here. We check whether the funds to withdraw is equal to 0. Okay, we check that. Okay, if it is equal to 0, then we say no funds to withdraw. Okay, we check whether the funds is actually 0. Okay, if it is equal to 0, then we say no funds to withdraw. Okay, if it is not, then we will actually proceed. Okay, So we'll say fund. Okay, we will have to make token transfer here. We have to make token transfer here and also here as well. Let me add some comments over there. To do token transfer, and we'll copy that. Paste it here. So we need to do token transfer. Okay, once we integrate our ERC20 contract, we'll do that. I'll show you how to do that. So after token transfer, we will change the ID to available withdraw to 0. Since we withdrawn all the fund here, so we'll make it to 0 again. Okay, so that next time it will be so that we'll have original values to withdraw, not so that people won't actually withdraw more than they have. Okay, so cool. So now we got all the functions ready. Now it's time to get have the modifiers ready. So before that, we'll have the token. Okay, we'll just have a token transfer ready. Okay, so to enable token transfer, the first thing is you need to install a couple of libraries. You have to import a couple of libraries. The first thing that we need to import is Open Zeppelin. Okay, contracts. Okay, token ERC20. Okay, and ERC20.sol. So you have to import the original ERC20 contract here. Okay, and then also you have to import one more utility. This is more of like a wrapper, a good secure wrapper on top of ERC20. That's called safe ERC20. Okay, it's really good. This safe ERC20 would really it's really helpful when you're dealing with ERC20s. And one more thing that we need is an interface of ERC20 functions. So we'll say IERC20. Okay, and at last you need one more value, one more contract. Basically this is a utility contract. So util counters. So remember, to generate dynamic project IDs, we need a counter, right? So we'll be importing counter, and these three contracts are for tokens. Okay, to enable us to transfer our tokens in safe manner. So here we'll have using. So we'll be basically using we're telling Solidity that we're using a external library, that is safe ERC20 and then counters. So here I'm gonna say using safe ERC20 for IERC20. So basically I'm wrapping up this interface of the common or the original ERC20 with safe ERC20, so that we get like many safe methods to while transacting with the ERC20s, since it has all these token transfers in it. And we'll say using counters. Okay, counters for counters dot counter. Counters dot counter. So now we're actually using counters here. Okay, so that we can get dynamic IDs. Now let's define these counters. So now we'll say counters dot counter. Okay, counters dot counter private. Okay, underscore project IDs or project ID, whatever you guys want. Okay, I'm going to name this project IDs, but whatever you guys want, you can call it. Okay, so this will give us this will basically give you numbers like 1 2 3 4, but it will handle many edge cases where when you're incrementing and decrementing, something might happen. So all these things will be handled by this counters properly. Okay, and then we'll have one more parameter here, variable declaration here, that is IERC20. So this will be private as well, and this will be fund token. Actually you can make this as public, because people can actually see what is the address of your token. So this will be fund token. Okay, now you have to create a constructor to basically update those data. So now right now these both are empty. Okay, this is 0 by default, but this token is empty. You don't have the token address here, so you have to update it. So we write a constructor. Again, you guys remember what is constructor, right? So we'll write a constructor that accepts the token ID. Okay, so that will accept the token ID as the parameter, say token. Okay, and it will update it. So we'll say fund fund token equals token. Okay, now you will update this address. Okay. Oh wait, you cannot directly update it like that. You have to wrap it ERC20 of fund token. Now this is enough. This will update the address on the your token contract over there. And now, so wherever you need to call this function, right, wherever you need all these transactions to do token transfer here, you can actually do it. So what we'll do is we'll say fund token dot save, okay, transfer from. Okay, here we are using transfer from because we are transferring from user's account to the contract account. So now what we'll do is we'll say msg.sender, okay, msg.sender comma address of this, okay, address of this refers to the contract address, okay, this contract address, and then the amount. So user has to approve this particular function first. So approve, we have to edit in the React code. Okay, we have to approve the transaction first, or else this will fail, this function will fail. Okay, now the token will be transferred. Okay, the fund will be transferred to this particular contract. Okay, and similarly we'll do the same thing here. So here we'll do the same thing. So we'll copy this and paste it here, remove that to do, remove, let's indent properly. Okay, and instead of save transfer from, you can use save transfer here. Okay, you don't need transfer from because you're not here you are actually transferring from user account to your address, but here you're transferring from your address to the user address. So you don't need this transfer from. You can just directly modify this to message.sender. Okay, this will be fine. Save transfer. Okay, wait, we have an error. Undeclared amount. Oh yeah, this is undeclared. We have to use funds to withdraw here. This is fine. Okay, now we can see we have the token transfer as well. So now this will transfer whatever the funds that is needed to be transferred from contracts wallet to the user, the project owner wallet, whoever is requesting. So now we were able to actually see all these fund project and then fund withdraw and everything. So people are able to add their project here. People are able to get all the projects. People are able to get projects by ID. People are able to fund projects. People are able to withdraw funds as well. Now the only thing that is remaining is for us to write some checks. Okay, you have to check few things whether everything is all right or not. So now we'll write those checks. That is called modifiers. So we'll say modifier. Okay, modifier only. Okay, only project owner. Modifier only project owner, and we'll say you win 256 ID. Okay, you win 256 ID, and then we'll say require. So require projects of ID. So we're checking whether the current person who is requesting to do some operation on the project is actually the project's owner or not. So we'll check whether if it's not equal to msg.sender, you are not project owner, and then we return it. So we're checking if the current project owner, if it is not equal to the message.sender, that is the current caller, then we are returning you are not a project owner. Okay, similarly we need one more modifier, that is project should be active. And this is optional, guys, since we don't have any function to actually deactivate the projects. You can skip this, or if you want it, you can also add it. Okay, here as you know, as the name only suggests, we're checking if the current project is active or not. So if the projects of ID dot is active, okay, if it is active, then okay, if it is active, then it's fine, or else this will say project inactive. Okay, and you can see I don't have any equals or anything here because this is a boolean value, right? If this will be false, then this will automatically update. Okay, now we return from here. and then we'll write one more modifier, one last modifier guys, and this will be check fund threshold. Okay, check fund threshold. So basically remember in while funding we were talking about like checking whether the actual amount is valid or not to fund. That's what we'll be checking here. We'll say we'll accept the project ID, we'll accept the amount of funding that's been sent by the user, and we'll check here. Okay, first thing is we'll first get the funds required. Okay, we'll get the funds required. So we'll say projects of ID dot funds required. Okay, now we will say require, okay, amount, whatever the amount that the user is sending should be lesser than the funds required. Okay, this is valid, right? This is straightforward. So it should always be lesser than the funds required. So if my fund required is 1 million, and if you're trying to send 2 million, it should not, it's actually invalid. It should throw an error because I don't need 2 million, right? I just need 1 million. So we'll say specified amount exceeds required funds. Okay, so we'll throw an error, and we need one more thing, that is require amount. Okay, we're checking whether amount plus, okay, amount plus projects ID of ID the total fund received. Okay, so first what we're trying to do is we'll first, okay, so what we're trying to do, we're first adding the current fund that has been received, right? The current fund that has been received with the amount that someone is trying to send. We're adding them, and then we are checking whether if it is lesser than or equal to funds required. So let's say my required fund is 2 million, and currently I have 1 million funded. All I need is 1 million more. And if someone is trying to send 2 million, then the current funding is 1 million plus 2 million, 3 million. That is more than my funds required, right? So we are checking this condition. Okay, so if you add the current total fund received plus the incoming amount, it should always be lesser or equal to the funds required. Okay, so then we say specified amount would exceed the current required fund. Okay, so now this way we can avoid all the invalid fund transactions. There is an issue. What is that? Got expected, but oh yeah, it didn't add semicolon here. Okay, now let's start adding this modifiers to appropriate places. So we can add it to fund projects here. So in fund projects, I'm gonna just make this into a new line so that it's properly readable. In fund projects, we need to check whether the project is active. Project should be active, and then we will pass the project ID, and then we'll also check funds, check fund threshold. Okay, we'll say ID and then amount. Okay, so this will verify everything before actually funding the project. And then here while withdrawing, so while withdrawing, the whoever withdraws should be the project owner, right? So it's not like anybody can come and withdraw the funds of the project. So we'll check only project owner. So we'll check only project owner, and then we'll pass the project ID. Okay, so this will enable only project owners can withdraw the fund. So here is, guys, this is what your contract should look like. See, so this will enable you to do all the operations like funding, withdrawing the funds, getting all the projects and everything. Now let's write one more contract to basically have our token, ERC20 token. So it's very simple. ERC20 token contract is really simple. So here we'll say 5 underscore fund token dot sol. Okay, fund token dot sol, and ERC20 contract is like max 10 lines, 10 to 12 lines max. So here we'll say pragma. Oops, let me zoom in. Solidity 0.8.2 again. Okay, and then we'll import at open Zeppelin contracts, okay, token erc20.sol. Okay, will be import only one contract, that is erc20.sol, and then we'll write the contract. So we'll write contract fund token, okay, fund token, and we'll extend it. Okay, we'll be extending this with erc20. Okay, remember in oops concept you have this class extend, right? You can extend the class, right? So same thing here, we're extending the erc20. Okay, and then we'll say constructor, and it's erc20, and you have to pass the token name. So our token name would be fund token, and then the symbol would be fund, fund. Okay, and then you can create your constructor task. So in the constructor we'll actually mint some tokens initially. So we'll mint to the owner, that is myself. If I'm deploying, if you're deploying, you will be the owner. So and then it would be around 10, or maybe we can also do it this way. So what you can do is you can have UN 256 total initial mint. Okay, you can have around let's say 1 million ethers. I think it's ether. Yeah, it's ether. Okay, this will actually give you amount in way. So now you can actually get 1 million of token initially minted when you deploy this contract to your address. Okay, if you are minting, it will be your address. And in the future, if you want to mint more, you can actually write a function for that. So we write a function that will accept the address. That will be, let's say, basically recipient, like which address you have to actually mint to, recipient, and then the amount, like how many tokens you have to mint. Okay, you have to pass this. This will be a public function. Okay, and then we'll actually mint it. So we'll say recipient and then amount. Okay, and guys, it's not a good practice to actually do it like this. It's public right now, anybody can call this function. If you're doing this on production or in application, there is a contract called ownable. Okay, in Open Zeppelin you have to import that, and then make sure to actually make this as only owner, so that only owner can mint it. If you do it in this way in production, anybody can mint tokens for their address but themselves. They don't need you at all, so your total supply will increase. So it's always best to have only owner attached to this particular mint functions. Okay, for now it's fine, but in case of production you have to do it. Okay. Open Zeppelin contracts not found. Did we make any mistake? Yes, we did. It should be token erc20 and then erc20.sol. Now this will work. Okay, it is compiled. Let's check whether crowdfunding will be compiled or not. Okay, it is compiled as well. Now let's deploy them. We'll deploy to Remix VM for now, and then we'll deploy to MetaMask tomorrow when we actually start with React application. Okay, so here I'm selecting first we have to deploy erc20 contract. So I'm going to go to my fund token, and then here you have to select your fund token.sol. Make sure it is fund token here and deploy. Okay, so you'll get everything, and let's check the balance now. So I'll check my balance here from the my caller address. So balance of, paste the address. So you can see I got here, it should be 1 million. It's in wave format, so you can copy this and Google ETH converter, ETH-converter.com, and then paste it in wave, and now we can see we got 1 million token in ether. Okay, so we have correct balance. Now what we can do is we can deploy our crowdfunding contract. So now make sure to select crowdfunding in the drop down here, because you're getting all these lists because remember you imported many contracts here. See, many different contracts is here. That's the reason you're getting all these drop downs. Okay, so make sure to select your contract address, the contract name, that is crowdfunding. Make sure that is selected here, and then it needs an address to deploy, that is token address, and then we deploy the token address right now, right? So we can copy paste that here. and then click on deploy. So this will deploy your contract, and now you can see you got token crowdfunding as well. And if you have this fund token, right, you can click on that, it will give you the token address, and you can verify that whether it's the same or not. You can see it's 39138 at the end, and it's 39138 at the end as well. Okay, so fund token is correct. Now what we can do is we can start listing our project. So now let me list a project. Okay, it says tuple here. You have to pass in a tuple way. So what is a tuple way? Basically, you have to pass it in an array of strings or array of objects basically. Okay, so let me pass an array of data here. So what is the data that I have to pass? It is project input, right? I have to pass project input. So what is the project input structure look like? You have to pass title, description, funds required, and then image. So let's pass that. Let's actually make a value here. I'll just comment it out. So here we need to pass it as an array. The first thing is we need title. We'll say my first project. Okay, and then description. Description would be a short details. Okay, and then we need one more thing, that is the funds required. So funds required would be like, let's say 1 million. So here you cannot pass this as 1 million like this, you have to pass the way format. So I'm going to copy this and pass it. Okay, this will be 1 million. And then you need an image URL. So here I'm going to just go and copy some image URL, just Google image, go here, copy a good image URL. I think this should be fine. Copy link address. No, this is actually a Google search address. This pixels and everything won't actually give you the address properly. Oh wait, it should be copy image address. Yeah, this should be fine. Okay, let's copy this, come back, paste it over there. Now what I'll do is I'm going to copy this. I'm actually storing this here because instead of typing every single time, I can just copy paste this a bit here. That's the reason I'm typing that over there. And once we send it from React application, it will be automated since you'll be writing code for that. But for now you have to send it manually. So now we'll paste that and then click on transact. So now we can see it was added. So the whole project was added. And then the project ID would be 0. Okay, if you want a project ID, you can scroll down and actually check here, decoded output is 0. Why? Because we are actually, oh yeah, we forgot to actually integrate counter here, right? Let's integrate counter. We have to redeploy the contract, and you can see we are returning the ID, right? So that's why it's 0. And we forgot to add counters here, right, for the projects. Now let's add counter. It's very simple, guys. All you have to do is you have to say counters dot current. Okay, counters dot current will give you the current ID of project IDs. Okay, so project ID is here that you define. Okay, and then you're getting the current value, and after updating everything you have to increment it. So here we will say counter dot increment project IDs. So this will increment the project ID. Now you will keep on getting updated project IDs. Okay, you can actually redeploy and test it again. We'll just redeploy and test it again. Let's do that. We'll copy the token address, paste it here, redeploy. Got it. Now we will get our data, the project data. Okay, we'll come back to our crowdfunding contract, paste list project, paste over there. It should be 0. The decoded output should be 0. Yes, it is 0. Now let's try to say my second project and click on list project. So now the decoded ID should be 1. You can see it is 1. Okay, now let's try to list the project. Let's say get all projects first. I'm going to click on get all projects, and you can see we got a tuple. So tuple of arrays. So you can see 0, we have my first project, and then 1 here we have my second project. Okay, so we were able to get all the project list in array format. And then let's say I want to get my project ID of 0. If I hit and if it get project, you can see we got it, my first project. If I say 1 and hit get project, you can see we got my second project. Okay, now let's try to fund a project. Okay, let's try to fund a project. Let's try to fund project 1. Okay, we need 1 million for that, right? So I don't have 1 million in my, I just have 1 million in my account, right? So what I'm going to do is I'm going to just fund 1000 tokens. Okay, let me say 1000 tokens here. So copy the way format of that, come back again. Okay, so my funding, I'll be funding for project 1 with amount of 1000 tokens. This will actually fail because you will see if I click on transact, you can actually see it failed. Why? Because insufficient allowance. Basically this is saying that it's trying to transfer, right? This crowdfunding token contract is trying to transfer some tokens from my account. Okay, it's trying to transfer 1000 tokens from my account, and I actually didn't approve it. I didn't allow it as well. So what's going to happen is I have to approve it. I have to say 1000 tokens can be allowed by this contract. I have to go to my token contract and I have to allow it. The spender would be the contract address, the crowdfunding contract address, and then this will be the amount, the 1000 tokens. Okay, and I have to approve it first. First thing is approve, and next thing is you have to increase. Okay, you have to allow it. So here I'll just copy the same amount. Okay, go to increase allowance and then copy the spender. Okay, transact. So now if you try to send, it should actually allow you. So if I click on transfer, you can see it was transferred now because I actually allowed it. Okay, now you can see it was transferred. And now let's just try to get the project again. Let's try to get project 1 again. And you can see here after true, it is here it's mentioned 1000. Okay, what is this here? Let's check in the structure. So if you go to structure, so total funds received is 1 2 3. It's third from last. Let's check the value third from last. So here we have the first value from the last, second value, and third value here, total fund received. So let's copy this value and paste it in ETH converter way. So if you paste it, we get 1000. So 1000 was funded. Okay, now let's try to withdraw this. Okay, let's try to withdraw. So I'm gonna say 1 and then I click on withdraw. It says you're not a project owner. Oh, okay. I made a mistake, guys. This should have been equals. Now this will actually work. Okay, so let's try this again. So basically we have to redo everything. I have to cancel this, redeploy. Okay, we redeployed everything. Now we basically have to add the projects as well. So I'm gonna add a project, list project. This would be 0, ID 0. We'll verify that once. 0. Yes, we're getting it. Now we'll try to fund it. So I'm gonna say ID 0 and I wanna fund around 1000 tokens. 1000. Before that, you already know we have to approve this. Since this is a new contract, you have to approve the spender and then you have to increase the allowance. Okay, and then you have to transact. Now funding was done. Let's try to withdraw. Withdrawing from project 0, and now we can see no funds to withdraw. Oh man, nice. If it is not equal to 0. Okay, so basically what's happening here is this required should be true. Okay, this condition should be true. Okay, only then this will pass. Okay, so now what's happening is when I say fund is equal to 0 here, okay, now what this is checking is, it is checking whether the fund is equal to 0 or not. Since it is not 0, it is throwing an issue. Okay, and if it was 0, it would have completed. Okay, since it was not 0, it was throwing an issue. So we'll say fund should not be equal to 0. Okay, now it should actually work. We'll cancel this, redeploy again. Few mistakes here and there cost us a lot of time. Okay, we'll copy this. See now how helpful it is that I actually stored everything here. I can just copy paste it and then complete this. Okay, let's verify once. Project ID 0. We have the project, and then we will add the funding. Project ID 0, funding amount 1000. So before that you have to again approve and then increase the allowance. I'm gonna just close this particular terminal for now since we don't need it. Okay, so approval was done, allowance was increased, click on transact. The transaction was done. I'm gonna open up the terminal now since we are withdrawing. So we'll withdraw from 0. Now we can see we withdraw the tokens as well. So we were able to withdraw. Okay, so we were able to withdraw as well. So this is how, guys, the whole thing works. Okay, so you can get the project list and withdraw as well. Now if you try to withdraw from some other address, it will throw an error. And now since I withdraw everything, the available to withdraw would be 0. If I try to withdraw now, it actually throws an error saying that no funds to withdraw. You can see now it's correct, right? Similarly, when you try with other addresses, it will say unable to withdraw. And now let's say that funding required is 1 million, right? Let's say I try to send around 10 million. Okay, this is 1 million. Let's say I send 2 million. Okay, 2 million. This will actually won't accept. Okay, even if I try to fund 2 million, you can see it would throw an error. Specified amount exceeds required fund. That's what we added, right? Specified amount exceeds required fund. See, it's throwing an error. So this is all about the crowdfunding contract, guys. I hope you had a good understanding here. So I'll be posting this whole thing in a GitHub gist in the description if you guys want the source code. So alright guys, so you can get the source code ready. Okay, so also we'll be pushing this to GitHub as well. So once we start with our React application, usually you can access this with our React as well in our GitHub. So yeah, alright guys, thank you so much. If you guys have any doubts, let me know in the comments.